Okay, this is another special case. Very, very important one, actually. Um, I call these conjugates, multiplying by the conjugate, x minus 3 times x plus 3. And we've talked a little bit about the conjugate, but a conjugate are conjugates are two binomials that have only a difference in one of the signs. So a plus b and a minus b are conjugates. 2x plus 5 and 2x minus 5 are conjugates. So what we're looking at here are conjugates. Now, the result of multiplying conjugates in these cases are called a difference of squares. So let's see what happens here. Let's use FOIL. We get x times x. So we get x squared. Then we get the outers are x times 3, so that's positive 3x. And the inners are x times negative 3, so that's minus 3x. And then negative 3 times positive 3 is negative 9. Okay, so the middle terms go away, leaving us with x minus 9, x squared minus 9. Okay, now our result here is a binomial. If you recall, when we were multiplying in the last video, our results were trinomials. These were always trinomials, but now we're multiplying two binomials, just like we were before, but we get another binomial. And that binomial is a perfect square minus another perfect square. And that's why this result is called a difference of squares. Difference being subtraction of squares. So we get a difference of squares. Let's see what happens when we multiply a times b and a, or a plus b times a minus b. I'll take another color out. Just this color's nice. So a times a, that's going to be, we're going to FOIL again, a squared. And then a times negative b is negative ab. And b times positive a is plus ab. So that's the outers and the inners, the outers and the inners. The outers was a times negative b, and the inners was a times b. And then the lasts, b times negative b minus b squared. And as you can see here, we have negative ab and positive ab. So those go away, leaving a squared minus b squared. Now, what this means is when you multiply conjugates, the middle term is always going to go away. Regardless of what the numbers are, the middle term disappears. And the first term in your answer is the first terms in the matching binomials squared. The last term is the two terms in the matching binomials, the end of the end pieces of the matching binomials squared, and we wind up with a minus between them. Again, there's a reason we call it difference of squares. So if we look at this, I'm not going to bother to multiply the middle for the first time. I'm just going to multiply 2x times 2x. I'm just going to multiply 2x times 2x, and of course get 4x squared. So this is going to be 4x squared. I'm not going to worry about the middle terms because I'm multiplying conjugates, and the middle terms go away. I'm going to have a minus here. I'm going to take 5 times 5, 25. 4x minus 25, and I'm done.